Okay, so let's get back into carboxylic acids. Okay, finish up the chapter on carboxylic acids. And what we're going to look at today are reactions. Of carboxylic acids. Okay. So if you're following your outline sheet, you'll see that we're down on section 4. Okay. And the first reaction we're going to look at is with alcohols. Alcohol. So what we're going to do is an example here. Okay, where we'll take this carboxylic acid, acetic acid, and react it with this alcohol, cyclohexanol, and note that we're using some acid catalyst. Okay, and let's see what happens here. Okay, just the shorthand product that you get. This alcohol, what it does is it substitutes for this OH. And so the product that you get is this thing here. Okay? Where, if you might remember, the name of this functional group is what's called an ester. All right, so this is the shorthand version. If I just ask for the product, the alcohol substitutes for the OH, and so we get this ester form. But now we want to look at it from the long perspective and look at the mechanism. Okay. So in this chapter, there's two mechanisms that you want to make sure you have mastered. One is this mechanism, and the other is earlier on when we did the Grignard reaction with the to make carboxylic acids. Okay? So let's look at the mechanism of how this works. And what you'll see in this mechanism is that it's very similar to the stuff we did with aldehydes and ketones. Okay, so I'll ask you questions, and it should be very obvious what happens in each step. Okay, so in the first step, just like in the past, the oxygen gets protonated. Okay, so that makes the carbonyl more reactive, just like in the past, more electrophilic. So that in the next step, when we bring in the alcohol, okay, note it's just regular cyclohexanol, it's not a benzene ring. Where do you think the oxygen's going to attack here? Okay, at the carbonyl carbon. Okay, so just the same old chemistry. that we've been doing. Okay, so that big clumsy alcohol has added on. And note we have oxygen with 3 bonds, so positive charge. So that makes that hydrogen what? Acidic, so we can remove it. So we'll bring in another alcohol to do that. So this alcohol will act like a base and take that acidic hydrogen off. And we get that structure there. Okay, kind of a halfway structure like we're used to in the past, like a hemiacetal or ketal. So if you remember in those past reactions, we took this and next reacted it with another H+. But here you have 3 oxygens that could attack it. Which of those 3 oxygens do you think will attack it? Okay. Well, if you look, if I use this oxygen, I'm going to go backwards. I don't want to do that one. So I can use either one of these. Okay? So either one of those oxygens will give us something forward. Okay? So let's go ahead and just choose this one. So if that gets protonated, right, you already see it ahead of time. Then you form water, which is a good leaving group. Okay, so just very similar to what we've done in the past. See how you master one, that helps you to master them all. Okay. So we lose water. And when we do, we form the carbocation, just like in the past. And what do we draw at this point? A resonance structure. So that gave us that there. Then lastly, what you can remove that acidic hydrogen to give you the final product. Okay. So we have a lot of steps here, but I think you were able to predict each step as we went along the way. Okay, see how you don't have to memorize, but each step kind of leads to itself what to do. Okay, so let's go back over this again and make sure we have it digested. Okay, so acid plus alcohol forms ester. Okay, first step, protonate, carbonyl, more activated, alcohol attacks, adds on, creates an acidic hydrogen, remove it, halfway point, either OH attacks the proton to give water, good leaving group, form the carbocation, resonance, and then remove that acidic hydrogen. Okay. Any questions on that? So that's the second mechanism you need to know from this chapter. Again, the first one is the Grignard with CO2 to form an acid. Okay, so those are the only two I'll hold you accountable for in the chapter. So in your outline, that's number 3D and 4A. 3D and 4A. Those are the two mechanisms. Okay, everything else just memorize the reactions. Okay, let's go to our next reaction of carboxylic acids. And that's using lithium aluminum hydride. What kind of reagent was lithium aluminum hydride? A reducing agent. Okay, so it's going to reduce the carbonyl. Okay. So our setup here is if we have an acid okay, just like when we did aldehydes and ketones, we used that. Okay, then there was the second step, just using H3O+. What did that convert the carbonyl to? The alcohol, right? The alcohol. Well, it's going to do the exact same thing here. It's going to convert that to the alcohol. Okay, so it's going to convert the acid group to CH2OH. Okay. Let's look at an example. Suppose we had benzoic acid. And we reduced. What would the product be? Okay, so it converts the acid group to CH2OH. So you get benzyl alcohol. Okay. Any questions on that reaction? Okay. Did you find making those cards helpful? So that when you saw the sheet of reactions, should have been a piece of cake. Okay. So for a lot of you, I saw that when I was grading those. I didn't have to use my pen just to give you a check mark. Okay. But some of you didn't get them, so there were a lot of X's, which wasn't pretty. Okay, but you put in the hard work, making the note cards, and it pays off, doesn't it? That feels good. Okay. All right, let's go to the next reaction, which is one we've already done in the last chapter. And that's reacting with the alkyl lithium. Remember that reaction? Let me remind you of it, just in case. Okay, so remember here you had the alkyl lithium. Okay, in this case, methyl lithium, and then H3O+, or you could use water. Remember what happened in this reaction? That's substituted for what? The OH. So it gave you the ketone. Remember that? Okay, so we got a little bit ahead of ourselves in the last chapter, but here it is again. Okay, so you'll get another chance if you missed that on the next test. Write it down again. Whatever is on the lithium substitutes for the OH on the acid group. Okay? And so you form a ketone. In this case, you get acetophenone. Okay? Any questions on these two reactions? Kind of review reactions. Okay? All right, well, there's one more reaction in this chapter. Let's look at this one over here. Okay, that's the use of oxalyl chloride or thionyl chloride. Okay, both of these reagents will do the same thing to a carboxylic acid. Okay, so let's look at the structures of these. Oxalyl chloride has this structure. Okay, you might remember oxalic acid. Remember that? It's the same thing, but these were OHs. So that's where oxalyl chloride is coming from. And thionyl chloride has that structure. Remember we looked at that back in 241. It's one way to make alkyl chlorides from alcohols. Okay. Thionyl chloride, you'll also see it written in its molecular formula of SOCl2. Okay? So be prepared for either way. So what these two are, these are both what are called chlorinating agents. What do you think a chlorinating agent is?
Puts on a chloride.
Yeah, it puts on a chlorine somewhere. Okay? Puts on a chlorine somewhere. Ever hear of a chlorinating agent used somewhere? In a pool. Yeah. Okay, disinfect the water. Okay, they don't use that, okay? So just, make sure you don't have that. Okay, so when you're swimming in a pool, you're not swimming in this stuff. All right, so what's going on here? Well, let's take a look at acetic acid once again. And react with oxylyl chloride. So we know it's a chlorinating agent, and what it's going to do is it's going to substitute one of these chlorines for the OH on the acid group. Okay, so that we get this new kind of molecule. Which is an acid chloride. Okay? We'll be talking about acid chlorides a little bit later. Okay? So both of these reagents do the same thing. If you took benzoic acid and reacted with thionyl chloride, okay, chlorine would substitute for the OH. Okay, so you can use either reagent to do this kind of conversion. Okay, and again, both of these molecules are what are called acid chlorides, a very important molecule that we'll be studying shortly. Okay, the only difference between these reagents is that thionyl chloride is a little more stronger than oxylyl chloride. So if you're in the lab and you wanted to make sure you chlorinated that acid, okay, use the thionyl chloride. It's just a more expensive reagent, so that's the only trade-off for using it, okay? Oxylyl chloride tends to take a little bit longer to do it. This one here does it very quickly. It's very powerful. Any questions on how to make acid chlorides? Okay, so this is the main way to make them. Okay. And what this does here is it opens the door to our next chapter, chapter 21. Okay? So chapter 20, pretty short. We only covered it in a couple of lectures. Chapter 21 will be a little bit more involved. chapter 21, a little bit bigger chapter called Carboxylic acid derivatives. Okay? So when you see the word derivative there, can anybody give me a definition of a derivative? Doesn't have to be chemistry-wise, but anything. What comes to your mind when you think of derivative? Calculus? Okay, that's fair game. Didn't think about that. Okay. Doing a lot of derivatives there? Anybody else? Another thing that comes to mind? An alternative? Okay. Didn't think of that one either. They're good. Anybody else? What's a derivative to you?
Like everything's been said already.
Anybody give me an example of an everyday derivative? What word do you see in derivative? Derived. Anybody think of something derived from something? Okay. One tree from another tree. How about you? Are you a derivative? Yeah, we're derivatives from our parents. So what does that mean that you're a derivative? Okay. Cell phones need to be put away. Purse, bag. Okay. So what does it mean you're a derivative from your parents? Came from anything else? Any similarities? Okay. Kind of? Okay, usually you do. Might look like one, might speak like one. Okay. And so on. Okay. Well, that's what carboxylic acid derivatives are. We can derive them from acids, and we're going to see they have some similar properties to acids. Okay. And go from there. So let me introduce you to them. So here they are in symbolic form. We'll unpack these with time. Okay, so you can see they kind of look like derivatives of acids, except maybe that fourth one, I don't know where that's coming from. But these are what are called acid chlorides, acid anhydride, amide, nitrile, and the ester. Okay, so these are our main molecules that we want to cover in this chapter. We're going to study their chemistry and so on. Okay? We'll see the chemistry of these things are very, very easy. Okay? So we've already been introduced to the acid chloride, so we'll go ahead and pick up on this one and then proceed down the line. Okay? So when you meet somebody for the first time, again, what's the first thing you always ask of them? Their name. And that's what we want to do here. Okay, so let's get introduced to them by learning how to name these things. Okay, so let's start with the acid chlorides first. Let's see the naming of these things, very simple. Okay, let's look at this simple acid chloride. Okay, 2-carbon acid chloride. You could see that it came from this acid here. Okay, we know how to convert thionyl-chloride or oxyl chloride. Well, remember that this 2-carbon acid is acetic acid. Okay, so how do we name the acid chloride? Well, what we do is we drop the ic acid and add YL and chloride. So we get acetyl chloride. Okay, so you see the derivative nature of it. Okay, what's another name for acetic acid? 2-carbon acid, what was another name for that? Ethanoic acid. Okay, so what would be another way to name that acid chloride?
Ethanol chloride.
Okay, right, so drop the ic acid. So we get ethanoyl chloride. Let me give you two, see if you can name them. Okay, take a minute to name those on your own. Who wants to come up and name the first one?
I'll try.
All right, you can do the second. Okay, step back. Have a seat. How many of you think she got that one right? grader says correct. Good job. Benzoyl chloride came from benzoic acid. Okay, so now you can come up and do the second one. Who wants to do the second one? I got to call on somebody. Green. Yes. I may think that he got that right. Raise your hand. See much confidence out there. Okay. All right, you raise his hand. Okay. Did you ever watch tennis on TV and they review it to see if the ball was in or not? So here it comes. Grader. You got it right.
So, Dr., we do count that carbon is,
That's right.
Okay.
1, 2, 3, 4, 5. Came from hexanoic acid. Okay. So let's call it there for today. I'll give you your exams back.